Okay, so here suppose I have one switch, or we have two switch. We have suppose two switch, switch 1 and switch 2. There are some user in VLAN 10 and there are some user in VLAN 20. In the same way on switch 2 as well, we have some user in VLAN 10 and some user are in VLAN 20. Suppose these two users are member of VLAN 10 and these two users are member of VLAN 20. In the same way, VLAN 10 and VLAN 20. Okay, and this is my trunk link, right? You are familiar with VLAN trunk, right? Access port, trunk port, right? Now suppose in VLAN 10 I am running 10 network, 10.1.1.1, 10.2. For VLAN 20 we are running 20 network, 20.1, 20.2, here 10.3, 10.4, 20.3 and 20.4. Okay, now I want to make communication possible between VLAN 10 and VLAN 20. Is it possible, guys?
No, it's not possible.
Not possible. Okay, tell me what will happen if I will make this interface to the member of VLAN 10 and this interface to VLAN 20. Can this user communicate with this user?
No.
Why?
The packet will drop.
So when this machine will generate ICMP request or broadcast message, on which device that broadcast message will drop? Switch 1. Suppose
Yes.
MAC address is A, MAC address is B. What switch will check? VLAN of this interface. This interface is member of which VLAN? VLAN 10. So switch will out this packet from this interface because this interface is also member of VLAN 10. When this switch will receive, they will check this interface is member of which VLAN? VLAN 20. That means this is a traffic for which VLAN? VLAN 20. So switch will out this from this interface. When this machine will generate reply, suppose B is MAC address of this machine. Source will be B and destination will be A. Am I right? When switch 2 will receive on this interface, switch 2 will check, okay, this interface is member of VLAN 20, so I will out this traffic from VLAN 20, so it will out from this interface. When switch 1 will receive, switch 1 will check, okay, this interface is member of VLAN 10, that means this is traffic of VLAN 10, so let me out from this interface. Am I right? Hello.
Yes.
Oh.
Yeah.
Inter-VLAN, because they are two different VLAN.
No, this is one way that you can make communication possible between two different VLAN as well. But for every VLAN, we need one cable between two switch. This is not effective. That's the reason why we are not using it. But you can make communication possible between different VLAN by manipulating port as well, right? I can make member of this interface to VLAN 10 and make member of this interface to VLAN 20. Then this machine can communicate.
But
Trunk or access.
one second, Praphul.
Yes.
Why is the need to have VLANs if they can communicate without configuring any task?
Okay, without configuring trunk, with the help of trunk they can communicate. You are thinking that with configuration of trunk between switch 1 and switch 2, this machine can communicate. VLAN 10 user can communicate with VLAN 20 user?
I'm asking about when you configure.
With help of the trunk, VLAN 10 can
So
communicate.
when trunk will add tag over here, right? When this switch will forward this traffic on trunk port. So before transmitting, it will add tag with your frame. In tag, VLAN ID will be 10. Now when switch 2 will receive on this interface, what switch 2 will came to know? Switch 2 will came to know that, okay, this is traffic for which VLAN? VLAN 10. So switch 2 will never out from this interface. Am I right? Because this interface is member of VLAN 20.
So you are saying like if we make code access between two switches,
Yes.
only then it will.
Yes, but it's not effective because for every VLAN we need a separate cable, but we don't have much port on switch to connect to switch together. Actually, we are using switch to connect my user.
Praphul,
But there
the way,
is some
can
problem.
you show me? Can you show me technically with GNS3, please?
Yes, sure.
I'm really confused.
Okay. See,
Sorry, guys. Yeah, Gobin and Ferras.
no problem at all, dear. Just wait.
We are in learning phase.
Yes. But you know there is some problem. You can see at layer 3 network is different, so we need default gateway in this situation, right? But if I will use same network, then you can see in packet tracer VLAN 10 can communicate with VLAN 20. Let me drag and draw some switch. Okay, my screen is visible to you, Khalid?
Yes, yes, yes.
Okay. This machine is member of VLAN 10 and this machine is member of VLAN 20, okay?
VLAN 20.
10, 20. Let me connect it. Let me configure IP. .10.0.0.1 on PC 1 .10.0.0.2 3 .10.0.0.3
When we try to enter duplicate IP address, Gracious ARP will tell us, right? That
Yes.
this IP is already being.
Now
It
I am
also
going
happen in real scenario, or it only happen
what
the Gracious ARP.
yes, in real scenario as well. Whenever you will configure IP address on your machine, right? First of all, your machine will generate Gracious ARP in real time as well in packet tracer. Okay, now I am going to make member of this interface to VLAN 10. Okay, so on switch 1.
Switch on power for your laptop.
Enable config terminal.
Yes, are you
Interface.
my screen is visible? Interface
Yes, yes,
fast
it's visible.
Internet 0/1
501
switch port
VLAN
access VLAN
access
10.
VLAN 10.
right? After that interface F0/2. Guys, you don't need to create VLAN. See, whenever a VLAN is not exist on your switch, and if you will make any interface to that VLAN will automatically created on your switch, right? So you can see creating VLAN. So interface 0/2. Now we don't have VLAN 20 on this switch, but if I will make member of VLAN 20 to this interface, VLAN 20 will be automatically created on this switch. Okay, So switch port access VLAN 20.
20.
Right? In the same way, let me do same configuration on switch number 2 as well. Enable configure terminal interface fast Ethernet 0/2 switch port access VLAN 10
Access VLAN 10
and interface
interface
F0/3
yeah.
switch port access VLAN 20. Right? Now you can see ping 10.0.0.2. I am not able to ping 10.2. Will it ping? Yes.
No, because you need to
Yes. We need
the trunk.
we need trunk.
Yes, you have assigned 10.2.
Okay, can I ping 10.3? Can I ping 10.3? We need trunk. We need a trunk link, right? First of
Yes.
all, let me configure trunk link.
Have you configured fast Ethernet 0/1?
Yes, in VLAN 10. So VLAN. You can see 0/1 is member of which VLAN? VLAN 10, and 0/2 is member of VLAN 20. Okay?
What about port which is going towards switch?
0/3. Okay, Govind?
Yes, configure that also. I just put VLAN.
0/3. Switch
Switch
port
port access.
mode dynamic desirable.
Why we are making a trunk?
First of all, I am going to show you that this machine can communicate with this machine, but not with this machine. Right? See, ping 10.3.
Not sure how PC0 and PC1 can
STP
communicate
is
with each
taking
other.
some time. What about PC0 and PC1?
If they are on different VLAN, how will
Yes,
they ping each
in
other?
real time, what you can do, we need two separate ports. Okay. This is 0/4 and this is 0/5. If you will make member of 0/4 to VLAN 10 and 0/5 to VLAN 20, then this machine can communicate with this machine as well. Okay. We need one Ethernet cable to join two interface together. I am showing you different method that how you can make communication possible between different VLAN. Okay, Khalid.
Yes, I'm here, sir.
See, I am able to ping 10.3, but I am not able to ping 10.4 because 10.4 belongs to different VLAN, right? Now what I will do, I will make this interface 0/3 of switch 1 to VLAN 10. To VLAN 10 and this interface to VLAN 20. Okay? See what will happen. On switch 0, switch 1. Interface F0/3. First of all, switch port access, switch port mode access. First of all, we need to make this interface as access port, right? And switch port access VLAN 10, right? Now you can see so VLAN. There are two interfaces in VLAN 10. Right, Khalid?
Yes.
Yes. Now on switch 2, interface is 0/1. Interface fast Ethernet is 0/1. Switch port mode
Mode
access
access.
and switch port access VLAN 20. Right?
Fast forward.
STP is taking some time. You can see this interface is in blocking state now. Yes, Viraj, just wait. We need router. But why this interface is down?
I can't hear you.
Yes.
Are you speaking?
No. I am not speaking. I am checking something. Just wait.
Okay. Sorry.
See dear. Khalid. Hello Khalid.
Yes, sir, I'm here.
Yes, you can see VLAN 10 are able to ping the user who is sitting in VLAN 20. I am pinging from PC 0. to PC3.
What extra configuration you have added?
Nothing. Just you need to make this interface to VLAN 10 and this interface to VLAN 20. Now you want to make communication possible between VLAN 20 to VLAN 10. You need one more cable between switch 1 and switch 2. Right? And what you need to do, interface F0/4 switch port mode access switch port access VLAN 20 interface F0/4 switch port access VLAN 10. Ping 10.0.0.3. See, this user is sitting in VLAN 20, are able to communicate with the user who is sitting in VLAN 10. But we need two cable because we have two VLAN 10 and VLAN 20. Okay, so that's the reason this is not an effective way, right? Khalid, is it clear to you? We can make communication possible without inter-VLAN routing as well, right? But not effective way.
Feras is saying we have 100 VLANs.
Yes. Then we need 100 connection between two switch. Right? Okay. On a real device, suppose this is my real switch and there are two users, 1, 2. This user is sitting in VLAN 10 and this user is sitting in VLAN 20. Suppose IP address of this machine is 10.1, IP address of this machine is 10.2. Now I want to make communication possible between 10.1 to 10.2. Is it possible to make communication possible between these two devices without performing inter-VLAN routing? Is it possible?
No, I think.
No. This is 0/0, this is 0/1, and this is 0/2, and this one is 0/3. If I will connect
because
these
there are two
ports
different
together,
broadcasts.
yes, if I will connect these two ports together, and if I will make member of 0/2 to VLAN 10, and this interface to VLAN 20. Now can this user communicate with this user? Yes or no? Can 10.1 communicate with 10.2? Yes or no? Yes. Firaj is saying yes. What about others? What do you think?
It's the same way that we did before.
Yes. Will it ping? Khalid?
Yes.
If I will ping 10.2 from 10.1, it will ping, right?
Yes.
But this is also not effective, right? We are using one Ethernet cable to make communication possible between two VLAN. If there is 100 VLAN or 50 VLAN or maybe 20 VLAN, we need again 20 cable, right? On every switch as well and between switch as well. So suppose there are two user who is sitting in VLAN 10 and VLAN 20. So we need two cable over here as well, right? And two cable between switch 1 and switch 2 as well. Then only these four computers can communicate together, right?
In Kinshasa it's acceptable, but not in London.
Sorry, Khalid?
In Kinshasa it's acceptable.
Yes. This is
But
how
not in
you
London.
can make communication possible without inter-VLAN routing. It will clear your trunking or VLAN packet flow, right? How packet will flow on trunk link, on access link, right? This is the reason why I am discussing this thing, Okay, now I have effective way. We have to switch switch 1 and switch 2. We are using a single link. Okay, this one is my trunk link. Here are some user in VLAN 10. Here are some user in VLAN 20. Right? Here are some user in VLAN 10. Here are some user in VLAN 20. Okay. So VLAN 10 user can communicate with VLAN 10 user. In the same way, VLAN 20 user can communicate with VLAN 20 user. Okay. Now if you want to make communication possible between VLAN 10 to VLAN 20, we need what? Inter-VLAN routing, IVR. Okay, we need inter-VLAN routing. But guys, my question is, why we need inter-VLAN routing? Why I will make communication possible between VLAN 10 and VLAN 20? Just I can remove VLAN as well, right? I can remove VLAN 10 from switch 1 and switch 2 as well, right? I will, if I want to make communication possible between this user to this user, I can make member of these all 4 port to the same VLAN as well. But there is one broadcast domain, right? So whenever user will generate broadcast, so that broadcast will always reach in this VLAN as well, in this domain as well, right? So what I want to perform routing, I want to make communication possible, but in different broadcast domain. Actually, with the help of VLAN, we are dividing broadcast domain, right? My concern is not stopping routing. Am I right, Khalid?
Yes, sir.
My concern is not stop routing with the help of VLAN. I want to divide. VLAN is a tool which is used to divide broadcast domain. Now see, there are 2 broadcast domain. VLAN 10, this one, and this one, VLAN 20. There are 2 broadcast domain. Now I want to make communication possible in these 2 different broadcast domain. We need one router. We need one router, and you have to configure this link as a trunk link. Oh, so when you will configure trunk link to this interface, so whenever switch will forward traffic on this from this interface, switch will add tag. Am I right? Switch will perform tagging, but router don't understand tagging, right? Router will never understand tagging. So we need to use encapsulation protocol on router as well, right? How many encapsulation protocol are there? ISL and .1Q. Right?
Thank you.
And guys, here how many VLAN are there? There are 2 VLAN, VLAN 10 and VLAN 20. So we need 2 interface on this router, right? And I will perform .1Q encapsulation for VLAN 10 on this interface, and for VLAN 20 I will perform encapsulation on this interface. Okay, so communication is possible. We need how many link? 2 link if there are 2 VLAN. If there are 10 VLAN, we need again 10 link between router and switch. Now what I can do, instead of using multiple physical link, I can create multiple logical interface on this router. That is known as sub interface. That is known as sub interface. Suppose this one is my 0/0. I can create 2 virtual interface. First one is like 0/0.1 and 0/0.2. This one is virtual link on this router. And on virtual link, I will configure .1Q encapsulation protocol, right? For which VLAN? For VLAN 10. And on this virtual link, I will configure encapsulation protocol .1Q for VLAN 20, right? So whenever switch will receive any traffic on this interface, it will check tag. If in tag value is 10, means VLAN ID is 10, means traffic is for this virtual interface. And in tag if value is 20, that means this is for this interface. So if there are 110 VLAN, we need to create 10 virtual interface. That means we need to create 10 sub interface on router. For 100 VLAN, we have to create 100 virtual interface. Okay. Now how communication will happen? Suppose, let me drag. Till now, do you have any doubt? Till now everything is clear?
Yes, sir.
Yes, Firaz, definitely. Okay, till now everything is clear. Then see how communication will happen between two different VLAN. This is switch 1. This is switch 2. There are two users in VLAN 10 and two users are in VLAN 20. In the same way on switch 2 as well. VLAN 10 20 20. This is trunk link and here is one router. This is physical interface of this router 0/0. Now I will create two sub interface on this router. First one is f0/0.1, second one is f0/0.2. This is I will configure encapsulation for VLAN 10 over here and for VLAN 20 over here. Now if I will ping, suppose IP address of this machine is 10.1 and IP address of this machine is 10.2, 10.3 and 10.4. Guys, this is recommendation. For every VLAN we should use different subnet as well, right? We are using private network, so you can use same network in multiple places, right? So recommendation is always use different network for different VLAN. So suppose here I am running 20.1, 20.2, here 20.3 and 20.4. Now if I will ping 20.3 from here, first of all let me show you. If I will ping 20.1 from 10.1, what will happen? Source IP will be 10.1 and destination IP will be 20.1. Okay, so 20.1 is belongs to different network, so we need default gateway. Am I right? So whatever IP address I will configure on this interface, suppose IP address is 10.10. So 10.10 will become default gateway for all the user who is sitting in VLAN 10. Am I right? For this user, for this user, for this user and for this user. Default gateway will be 10.10. What will be the source MAC? Source MAC will be suppose A and destination MAC will be suppose B. A, B. Now switch will receive on this interface, right? And this interface is member of which VLAN? VLAN 10. So it will forward on trunk port and on the port who is member of VLAN 10. So from this interface as well, right? Okay. Now don't think about this packet, about this frame. Let me discuss on this frame, right? When switch 1 will transmit frame on this trunk interface, what switch 1 will do? Tagging. Switch 1 will add one tag for which VLAN? For VLAN 10. When router will receive this traffic on this interface, on which interface router will receive this traffic? On virtual interface 0/0.1, because here we are running encapsulation.1 queue for VLAN 10. So router will remove tagging and router will check what? destination IP address. Destination IP address is 20. It will look up their routing table. In routing table, you will configure 20 network on this interface. Suppose here I am running IP 20.10. Oh, so 20 network is connected on a virtual interface, that is 0/0.2. So router will out this traffic from this logical interface. So before transmitting, it will add tag, because we are using encapsulation protocol on this interface. So it will add tag of which VLAN? Of VLAN 20. Here we are running encapsulation protocol for VLAN 20, so it will add one tag of VLAN 20, and router will out this packet from this physical interface. When switch will receive, what switch will check? Tag. In tag, value is 20. So okay, it will say it can send to this user also if they don't have updated MAC address table, to this interface also, and on trunk interface. When switch 2 will receive, switch 2 will check tagging. In tagging, value is 20, that means this is traffic for VLAN 20. It will out from this interface. When this machine will generate reply, or from this interface also, right? So when I am pinging 20.1, so this machine will generate reply, this machine will generate reply, right? On this switch, no one machine will generate reply, because 20.1 is my destination IP address. So this machine will generate reply, right? When this machine will generate reply will reach to switch 1. Switch 1 will check VLAN ID of this interface. VLAN ID is 20. It will forward on trunk interface, right? And add one tag of VLAN 20. When router will receive, router will check tagging. So this is for this virtual interface. This virtual interface will check destination IP. So destination IP will be 10.1 now, because this machine is generating reply. So in reply, destination will be 10.1. Okay, so router will check their routing table. In their routing table, there will be one entry for 10 network, right, which is connected on this virtual interface. So it will out this traffic from this virtual interface with one tag of VLAN 10. When switch 1 will receive reply, switch 1 will out from this interface, because there is tag of VLAN 10, right? This is how two different VLAN user can communicate with the help of router. Your communication is happening through router. This is my reply, and this is my this was my request, and this is my reply. Yes, any dot? Yes, sorry, someone was speaking. Till now, is it clear to everyone? Khalid, Govind, Firaz, please let me know.
Yes, sir.
Okay, now who will explain what will happen, how traffic will flow when I will ping 20.3 from 10.1? When I will ping 20.3.
We need first to absorb to absorb the explanation, then we can explain again.
These two ports are member of VLAN 20 and IP address is 20.1. Here is one router. We have two virtual interface 0/0.1 and 0/0.2. Right, here I am running IP 10.10, here I am running IP 20.10. Here we are running encapsulation for VLAN 10 and here we are running encapsulation for VLAN 20. Can 10.1 ping 20.1? Yes or no? Trunk. Can 10.1 ping 20.1? What do you think?
Yes.
Yes. Can you explain packet flow? Govind?
Yes, I can explain. 10.1 will generate a packet with destination 20.1.
Okay.
And
So
it
source
will
will be 10.1 and destination will be 10.2, 20.1, right?
Basically, it should be 20.1 indirectly, but it will pass the packet to 10.10 to its default gateway
Yes.
only.
Source MAC will be suppose A and MAC address will be B. Okay, so this frame
will
will
pass
be on switch.
with the switch 1, then it will see.
Switch will look up their MAC address table.
Yes,
They will update their MAC address table.
correct.
After that, they will check destination MAC is B
B
and this interface is member of which VLAN?
10.
VLAN 10, right? So on this interface there will be something different. There will be some different MAC address, suppose C. So it will not out from this interface, and this interface is VLAN member of VLAN 20. So switch 1 will not out from this interface as well, right? But there are two trunk port. Okay. So switch will out this frame from this interface and from this interface, right? Okay, so one frame is on this trunk link where source IP is 10.1 and destination IP is 20.1, and there is one tagging. In tag value will be what? 10 na? Because
Yes,
when
VLAN
switch
10.
1 will receive on this interface is member of VLAN 10, so it will add tag of VLAN 10. When switch 2 will receive, switch 2 will check that which interface is member of VLAN 10. There are some member of VLAN 10, but their MAC address is different, right? So switch will drop this frame. Am I right?
Yes.
Because in the MAC address table of switch 2 there will be no entry for the destination MAC which is present in VLAN 20.
If
Sorry,
we ping within same VLAN, it will not go to
Yes.
gateway.
But let me talk about this packet. Oh my god. Okay, what about this packet? So here is one packet where source is 10.1, destination is 10.2. Source MAC will be MAC address of this machine and default destination MAC will be MAC address of default gateway. Am I right? Note B. When router will receive this frame, what router 1 will do? First of all, router will check what? First
Default
of all,
gateway information.
yes. So router will came to know that this is traffic of which VLAN?
10.
10. So after that router will check destination IP. Destination, actually to forward traffic router will check destination IP, right? Like switch is checking destination MAC address, router is checking destination IP address. So destination IP is 20.1. Then router will check their routing table, and 20 network is directly connected on which interface? On this interface, right? So switch will out this traffic from this interface. But here we are running one encapsulation protocol for VLAN 20. So router will add one tag, right? So in my reply there will be tag of VLAN 20. Now again switch 1 will receive, and again switch 1, what switch 1 will do now? Switch 1 will check their MAC address table, they will update. After that, destination MAC address. Destination MAC address will be MAC address of this machine. Now destination, when router will forward this traffic from this virtual interface, destination MAC will be MAC address of this machine. If there will be no entry in their ARP table of this router, router will generate ARP request to find MAC address of 20.1. Am I right? I had discussed packet flow. Here I am not going to discuss packet flow. Okay. Now when switch will receive reply, what will happen, Govind? Switch will check tag first of all. Tag is 20. So there is no any interface whose MAC address is B and present in VLAN 20, because this is traffic of VLAN 20. So it will forward from trunk interface with one tag of VLAN 20, right? When switch 2 will receive, but switch 2 will check tag. So in tag VLAN ID is 20, that means this is traffic of for VLAN 20. Let me check destination MAC address. Destination MAC address is B. Destination MAC will be B, and in their MAC address table of this switch there will be one entry that this interface 0/0 is member of which VLAN, VLAN 20, and MAC address of this machine is B. So switch 2 will out this frame from this interface, right? And in the same way this machine will generate reply, and your reply will also come via router, right? Hello, clear? Let me show you practically. Switch 3 and switch 4. In VLAN 10, in VLAN 20, in VLAN 10, in VLAN 20. Right, now we need one router. You can use router on this switch as well, right? And okay, first of all let me configure IP. Default gateway is suppose 20.0.0.10. Let me configure default gateway on this PC as well. Default gateway is 10.10. On this machine I am going to configure 10.2. Default gateway will be same 10.10. .0.0.2 default gateway will be 20.10. Let me configure this interface and this interface as trunk. I will form trunking with the help of DTP protocol. Interface fast Ethernet 0/3. Switch port mode dynamic desirable. Okay, but 0/4 switch port mode dynamic desirable. You can see by using this command I am not able to configure this interface as trunk interface, right? Because on router we are not running DTP protocol access. Let me configure access again. Now I can configure this interface as a trunk interface manually, right? So switch port mode trunk, fine. So interface trunk, okay. Let me run no shutdown command on router. Enable configure terminal interface F0/0 no shutdown, right? Now on switch 3, so interface trunk, you can see 0/3 and 0/4 are trunk port, right? Now let me make member of 0/1 to VLAN 10 interface F0/1 switch port access VLAN 10 exit interface F0/2 switch port access VLAN 20. In the same way on this switch as well. Enable configure terminal interface F0/1 switch port access VLAN 10 exit interface F0/2 switch port access VLAN 20, right? Now let me do configuration on router. So first of all on router we need to create sub interface, two sub interface. So interface fast ethernet 0/0.1. After running this command you can see the log message. Interface fast ethernet 0/0.1 change state to up. After that IP address is 10.0.0.10.255.0.0.0.
And the encapsulation?
Encapsulation, you can see that's the reason why I am not able to configure IP address. Encapsulation .1q, here you are getting only this option .1q, but on real device you will get two options, .1q as well as ISL. ISL is an open standard, sorry, .1q is an open standard and ISL is an Cisco proprietary protocol, right? But nowadays Cisco is also not using ISL. After that, for which VLAN? For VLAN 10, am I right? Then IP address is 10.0.0.10.255.0.0.0. After that we need to create one more virtual link, virtual interface, one more virtual interface or sub interface. Okay, now I can't configure IP address before configuring encapsulation. Encapsulation .1q for which VLAN? For VLAN 20. After that IP address is 20.0.0.10.255.0.0.0. Now let me ping which machine do you want to ping first? 20.1. see, there is one ARP message. First of all ARP message will reach to switch and switch will forward on trunk port, and this is a broadcast message. Here you can see this is your actual ICMP message. No, broadcast message. This is my ICMP traffic. See, my ICMP traffic will reach on switch. Switch will forward on trunk interface. Switch is not forwarding from this interface. Why? Why? Because of destination MAC. Destination MAC will be the MAC address of default gateway, right? So there will be one entry in MAC address table of this switch. MAC address of default gateway is this one, and that interface is connected on this trunk interface. This is STP message, leave it. How to filter STP traffic? Edit filter. Okay, I don't want to see RIP packet, HSRP, DHCP, BGP, no, AGRP, no. I want to see the information of ICMP only. Okay, now let me ping 20.2. See, my ICMP traffic will reach on switch. Switch will check their MAC address table and it will forward on this trunk interface. Now router is dropping, so it's not pinging. It will not ping. First of all, let me check, is it pinging or not? Request timeout. Yes, it's pinging. First traffic will be dropped because of ARP. Router will generate a ARP request to find MAC address of this machine. So that's why first traffic will drop on your router. Now, but if I will ping now ARP table is updated. Now you can see this is my ICMP traffic. Traffic will reach on switch. Switch will forward to router. Router will forward to switch. Switch will out from this trunk interface. Switch 2 will out in VLAN 20. VLAN 20 user will generate reply. Reply will reach to switch. Switch will forward on trunk interface. After that, this switch will forward to router. Because of destination MAC address, because when this machine will generate reply, destination MAC will be MAC address of 20.10, right? Default gateway. This is how two different VLAN user can communicate with each other. Clear? Is it clear to everyone? Inter-VLAN routing.
Yes.
And in the same way, what we can do on switch, on layer 3 switch, I can create SVI. VLAN 10 user, VLAN 20 user. Okay, if I will create two virtual interface on this switch, suppose my virtual interface is 0/ VLAN 1 and VLAN 10. VLAN 10 and VLAN 20. These are my two virtual interface. Okay, if I will configure IP 10.10 over here on this interface, on this virtual interface, and 20.10 on this virtual interface. In the same way, these two users can communicate. Am I right? Here you are running encapsulation.1q for VLAN 10, and here you are running encapsulation.1q for VLAN 20. So there is not much difference in SVI or router on a stick. Router on a stick First method is router on a stick if you are using a router to perform inter-VLAN routing, and second option is SVI. So for SVI we need layer 3 switch. Okay, now can I move to STP again? Hello Firaz, should I start STP states now? Yes. Yes. Okay. So now topic is STP states. How many states are there?
5.
5. Okay, let me open my board.
4.
4. Which one?
Down, low.
Blocking, listening, learning,
Start with
and
down.
forwarding.
Disable.
Okay.
Blocking.
Listening, learning, and forwarding.
Learning and forwarding. States. Okay, let me talk about port as well. Port. So guys, what do you mean by disable state? First of all, disable state means on that interface we are not running STP. On that particular interface we are not running STP, or that interface is shut down. That interface is shut down. So if an interface is shut down, right, that interface will not send any Bpdu. That port will not send any Bpdu as well as any data. So if I talk about disable port, right, that port will not send any Bpdu, not send and not receive. Talk about data, so that interface can't send data as well as they can't receive data, right? If I talk about MAC learning is also function of switch, MAC address learning. So on that interface which is disabled, on that interface switch will not learn any MAC address as well. Okay, disable means we are not running, that interface is down. Okay, that interface is down, so any data will not received on that interface. That interface is disabled. Okay, disable means switch will not learn any MAC address on that particular interface, switch will not receive any data, and switch will not send any data, and switch will not receive any Bpdu, as well as switch will not transmit any Bpdu from that interface. Is it clear to everyone? Disable mode, disable state. Okay, now let me talk about blogging state. Blogging state is second state when you will run no shutdown command, or when STP will enabled on a interface. That interface, that port will move in blogging state quickly from disable state to blogging state quickly, right? But in blogging state, switch can't send any Bpdu and switch can't receive any Bpdu. In the same way, switch can't send any Bpdu and switch can't receive any data. Means switch can't send Bpdu as well as data, switch can't receive Bpdu as well as data, and switch will never learn MAC address on that particular interface as well. Okay, so blogging state is second state. Quickly switch port will come in blogging state from disable state. But in blogging state, switch will not send any BPDU, switch will not receive any BPDU, switch will not send any data, switch will not receive any data, and switch will not learn any MAC address on that particular interface. Okay. Now state 3 is listening state. Guys, in listening state, what switch will do? Switch will receive BPDU. Switch will transmit BPDU. Switch can receive BPDU as well as switch can transmit BPDU, but switch can't send data from that port. If we have a port whose role is listening, in listening state, switch can receive BPDU, switch can transmit BPDU as well, but switch can't receive any data, switch can't send any data, right? I am talking about user data. So switch will not send any data and switch will not receive any data, and switch will not learn any MAC address as well on that particular interface. Okay. And in blogging to listening, quickly port will shift in listening state from blogging state, right? First quickly switch will move from disable to blogging, then blogging to listening very quickly. But if HTTP will block one port, so always remember that port will not receive any BPDU, not send any BPDU, not receive any data and not receive any data, not send any data and not receive any data. So what HTTP do? HTTP will put one redundant path in blogging state, right? So on that interface, switch will not receive any BPDU, switch will not send any BPDU, switch will not receive any data, switch will not send any data. So how loop will form? After that, in listening state, port will spend 15 seconds. How much time they will spend? From listening to learning state, it will spend 15 seconds. It will spend 15 seconds. And in learning state, switch can send BPDU, switch can receive BPDU, switch can not send data, switch cannot receive data, but switch will start learning MAC address. Switch can learn MAC address in learning state, right? So switch will learn MAC address in learning state, right? In this state, switch can make entry in their MAC address table, that on this interface user is connected whose MAC address is this one. And after spending 50 seconds in learning state will be moved in forwarding state, right? And in forwarding state, switch can send BPDU, switch can receive BPDU, switch can send data, and switch can receive data as well. Switch can learn MAC address as well. Okay. How many states are there? There are only 5 states. Blogging, disable, blogging, listening, learning, forwarding, right? In disable, switch can't receive or send BPDU, switch can't receive and send data, switch can't learn MAC address on that particular interface, on that particular port. In blogging state, in the same way, switch can't send, can't receive data and BPDU as well, and switch can't learn MAC address. But in listening state, still switch will not send any data and not receive any data, and they will not learn any MAC address. But yes,
Praphul,
yes,
from blocking state to listening state, it should take 15 seconds.
yes,
From blocking to listening, and from listening to learning is 15 seconds.
it will
But
spend
from
15
learning
seconds. It will spend 15 seconds in that particular state, in listening and in learning.
But all together should be 50 seconds.
Actually, suppose this is my interface. Now by default, this is in disable mode. When I will run no shutdown command, it will move in blogging state, then in listening state, and it will spend 15 seconds in listening state. So whatever BPDU they will receive on this interface, because in listening state they can send as well as they can receive BPDU. So either switch want to send BPDU from this interface, if switch will receive any BPDU, switch can understand. So it will spend 15 seconds, right?
In which interval? Blocking to listening?
In both, in listening as well as in learning. They will spend 15 seconds in listening state and 15 seconds in learning state. 15 seconds in learning state
20.
means in 50 seconds they will learn MAC address, they will learn BPDU, right? On which interface I am receiving BPDU.
But in forwarding state should be 20 seconds by default.
30 seconds. Switch is taking 30 seconds to come in forwarding state from disable state. 20 seconds is max aging time. Okay?
Okay.
Max aging time means whenever a switch will receive any BPDU, switch will hold that BPDU for how many time? For 20 seconds. That is max aging time, right? Switch will take 30 seconds to come in forwarding state from disable state. Is it clear to everyone? States of STP. Clear? Any doubt to anybody? You can ask. CCNP course fee. Fine, Gobind?
Yes.
Okay. Now there is some problem. Suppose this is my switch. Here is one user. Now to communicate to any other user, this user have to wait for 30 seconds. Am I right? This user have to wait for 30 seconds because this port will take 30 seconds to come in forwarding state from disable state. Am I right? So every day whenever you will attach your computer through switch in company, you have to wait for 30 seconds, right?
Is STP by default enabled?
Yes, by default STP is enabled. So we have one feature in STP, that is
port fast.
Port fast. Port fast. Port fast is an feature of STP. Feature of STP, spanning tree protocol. If you will configure port fast on a interface, that interface will quickly come in forwarding state directly from disable to forwarding. It will not take 30 seconds because if you will configure port fast on an interface, what switch will understand? Switch will understand that that is a access port. A user is connected there. Why switch will send any BPDU from this interface, right?
It will never expect to receive a BDBU.
Yes.
From that interface.
Yes. So switch will came to know that this interface is my access interface. So let me disable STP from this interface. Let me stop sending BPDU from this interface. Let me stop expecting receiving BPDU on this interface, right? Because there is user. So on every access port, we need to configure this feature, right? Then only user will directly come in forwarding state. You can check it in packet tracer as well. See, this user is taking
30 seconds.
What happened? Okay, so this is my simulation mode. If I will connect, it will take 30 seconds to come in forwarding state. Right, because of STP. So here we need to configure port fast feature. How can I configure?
You need to write spanning tree port fast.
Enable. We have two options. Either you can configure on interface mode or in global configure mode. Do you know how to configure port fast?
On switchboard, I know.
Okay, tell me command.
Spanning tree port fast.
Spanning tree
Port fast.
port fast. After that, there is one option you can see default. If I will run default, that means on every access port this service will enabled. On every access port, not on trunk port. There will be much problem if you will configure port fast on a trunk port. Right? Or you can configure on interface as well. Interface F0/1. And command is
Same. Spanning tree port fast.
Spanning tree port fast.
spanning tree
Port fast.
port fast.
It always give similar error in clear devices.
See, let me run shutdown command and let me run no shutdown command. It's not taking any time, right? Am I right?
Yes. I think basically it skips 3 states in between.
Yes.
Local
Port
learn.
fast will skip learning and listening state
Listen.
because that two state was taking time. Okay, so on every access port you will configure port fast feature, and we have two more feature we will discuss tomorrow. First one is Bpdu guard
Correct.
and root guard.
Correct.
Yeah, I heard same things.
Okay,
They are configuring these
Yeah, this, the
ISP
primary and the secondary
facing
feature.
interfaces only.
yes. So Bpdu guard is to protect root port, right? And root guard is to protect root breeze. To protect root breeze.
I
We
have
will
only
discuss
seen-
tomorrow how
yes.
attack can be.
Yes.
Attacker
I have only seen this configuration on ISP facing interfaces.
Okay.
Like if ISP is connected on
So-
switch 1 port 10, then we configure this.
So tomorrow
Bpdu.
first we will discuss how an attacker can attack in my network with the help of STP. Okay. Then we will discuss about these two feature. Then we will move to which topic? Ether channel. Your next topic is Ether channel. Okay. So if
Okay.
you have any doubt, you can ask. Otherwise, that's all for today.